Hi, everyone. Can you hear me? Yeah. Excellent. You can scan the QR code. You can also scan it in the end as well. You'll know why to scan it. But basically, it's access to Superlinked server, waitlist. We can send you more information. Yeah, I'll let you take a minute. Hi, I'm Ben, co-founder, COO of Superlinked. So not very technical, so don't ask me hard questions, but I'll tell you about what we do and why we want to do vector search over complex data. Oh, need the clicker. Great. All good? I'll move on. Oop. Sorry? Yeah. Okay. So why? Why do you want to do vector search over complex data? So you probably know Algolia. They've been serving a bunch of companies, especially in the e-commerce space with search. And ChatGPT is driving a new phenomenon. People are entering more keywords into the search box, right? You get used to asking complex questions, and people use it everywhere, not only in ChatGPT. And so they've seen double the number of keywords in 6 months after the launch of ChatGPT. And so let's talk about a query which is relatively simple, actually. Recent news about crop yield. So let's say you are working for some kind of analyst website where analysts go to find information about topics they care about, and they enter this question of recent news about crop yield. Right? This is an analyst in agriculture, and this is what they care about. So how should we handle that query? So a naive way would be to, let's just turn it into SQL, select, asterisk from news, where created at now -7 days, an article like crop yield, right? So this is one way of handling this, and we'll now talk about why this is challenging, right? So first of all, what is like crop yield? What if those words don't actually appear in the article? Great, we now have large language models, we can use those, right, to handle this. And so we can calculate cosine similarity between the article, we embed the article, we calculate cosine similarity to crop yield, and we sort by the most relevant articles. So that's solved, kind of. We'll talk about this. But what about the 7 days, right? So this is a hard filter. So actually, what if the most relevant results is 8 days away and not 7 days away? You kind of have to set a certain number here which cuts off your result set. And if we look at some Google trends of searches around crop yields, you'll see that, well, there are spikes, right? There are certain periods where there are news, and there are certain periods when there are no news. And so you don't want to necessarily say, well, 7 days. Maybe you need a longer period of time. Great. Well, let's just sort, right, both by the cosine similarity and by the date of creation. That should work, right? Well, actually, if you know SQL, it wouldn't, right? Because it will first sort by cosine similarity and then sort by date, right? So that doesn't work. So what can you do? You can do, again, we're going back to the 7 days issue, right? And then we order by the cosine similarity. And then we can also re-rank candidates using a function. So that's kind of working, right? But again, as we discussed, what if the perfect result is 8 days old? And what if your best result is not within the top 1,000 results that you retrieved, right? Now, let's move to something a little bit more complex, okay? So recent popular trustworthy news about crop yield, right? So this is now becoming really, really complicated. And by the way, if we start using filters, and we look at the intersection of those 3 areas, and actually the intersection is quite small. So if we start using filters, it's actually quite easy to lose the right result, right? Because the number of the suitable results is very small. So how should we think about this? We should think about it as a vector space, right? Where we basically try to match those 3 parameters, blend those 3 attributes, right, to maximize the result. So maximum trustworthy, maximum recent, and maximum popular news. So we should use pure vector search to do that, right? And that's why we talking about vector search over complex data. Now, how do we do that? So we'll encode all the information we have into vector embeddings, and we'll encode the queries into the vector embeddings, and then we use the query as a search vector within the vector database. So far, so good. Now let's talk about how do we do it. So we'll just stringify everything, use OpenAI API to get the vector embedding for the article, right? And you see there are attributes here as creation date, as number of likes or popularity, and the score of a moderator for trustworthiness. We'll do the same for the query, right? So again, we'll take the query and we'll encode it with OpenAI, and then we'll try to match them. Now, where is the problem? So LLMs are pretty bad in dealing with structured data or, for example, numbers, right? So here is one example where we encoded popularity between 0 and 99, right? And then asked the OpenAI model to retrieve us the most popular results, right? Based on this popularity score. As you can guess already, they didn't yield good results. So these are actually the results. So you see popularity 1 is part of those top 10 most popular results. So LLMs are great for text, not so great for structured data, not so great for numbers. And you can also see this chart, which actually shows the cosine popularity of the different popularity scores, right? So as you see, it's not what you would expect. You would expect a cosine similarity going pretty much in a straight line. Good, so that's an issue. So what are the other options we have? So you can train your custom embedding model for data and for the queries, a bit difficult. Or you can build your embedding model from pre-trained parts, right? And so this is hard, so we'll focus on the second option. So how would you do that? You would collect your data, and you maintain the types of the data, so it's a typed schema, right? So for the date, for the number of likes, and for the moderation score. And you encode those properties into the vector embedding, right? And that creates the news vector. On the other side, you do the same for the query, right? So you encode the freshness expectation, the popularity expectation, trustworthiness, and of course the query itself into a query vector, and then you match those two, right? Now, how do you do that with natural language queries? We'll talk about it in a second. But then you also want to create some feedback loops. So as a user interacts with the results you gave them, you want to learn something about the user. What do they prefer? Do they prefer fresher results? Do they prefer more popular results, etc.? How do you build this feedback loop? So, of course, collaborative filtering is one option. Fine-tuning of the embedding model is another option. But the ROI on those is not clear. But you can also create vectors based on events, and you can assign weights to parts of the vector based on those events. So now we finally go to Superlinked. So what is Superlinked? Superlinked is that platform that helps you embed complex data and then query it through natural language in runtime, right? And also treat the events and the feedback loop. So we take all the available data, so not just the textual features, not just the unstructured data, and we serve a bunch of use cases. So one of them that we talked about is basically semantic search, but that also fits RAG and recommender systems and analytics, so clustering and grouping of different events. And by the way, we have a connection to MongoDB. One of the reasons we are here, we recently partnered with Mongo. And so what is Superlinked? Similar to what we looked at earlier, you define a typed schema of your data. So news, you define a schema of a user. So that would be the user that makes events or activities with the results. And you have the event schema as well. And then what we do, we provide encoders for structured data types. So for example, for timestamp, for numerical space. And we also help you use any large language model that you like for encoding of the unstructured data, or in this case, sentence transformer model from Hugging Face. What do you do with that? You then combine them. Index is basically your vector embeddings. You combine those different parts of the embeddings into one, and you can also define how the events affect those embeddings. And you do the same on the query side, right? Um, Sorry, just moving on. And by the way, we launched a server. It's open source. You can go and check it out on GitHub. And it has, you can try it in a notebook. You can try it in an online executor. See what types of data are relevant, do a bit of feature engineering, and then you can actually deploy it in your cloud and connect to your favorite database, including, of course, MongoDB. And then you can also compile to Spark for any type of batch processing. And then we automatically create cloud APIs that you can then connect your application to. And here you also see the different weights, right? So based on the user, based on your understanding of the use case, you assign weights to different parts of the vector. So in this case, recency is the most important, popularity and semantic weight at next, and trust is maybe not as important, but you also want to take it into consideration. Now, by the way, one feature we have, if you don't know how to set up those weights, we have a feature called NLQ, which is Natural Language Query, where we actually use an LLM to translate the query into the weights which fit the user request. So basically taking something like recent news about crop yields and translating it to the right weights for different parts of the vector embedding. And by the way, we also have a bunch of community-generated resources about vector embeddings, about how to work with vector embeddings and why. One of them is Vector Hub, about 30 articles, community-generated mostly, about how you build with vector embeddings around a bunch of use cases. Again, RAG is obviously one that features quite a lot, semantic search, etc. And we also have the vector DB comparison table, where we have 40 vendors, again, who submit PRs. We have a member of a community who actually checks those PRs, approves them or rejects them, and you have a table which has an up-to-date view of about 40 vector databases in the market currently. And that's it. Thank you so much. And if you're interested in learning more, getting more information, okay. If you're interested to learn more information, yeah, you can definitely fill out the form.